All right, everybody, we're going to be talking about energy flow during phase changes, so let's get started. So, whenever we have a change of state, there will be a movement of energy either into the substance or out of it. So we're going to take just a little bit of time to introduce a little bit more of a technical description of this and to clarify this for you so that it's easy for you to understand. Okay, so basically there's two ways that energy can flow during a phase change. Energy can flow into the substance, or energy can flow out of the substance. Okay? So in science, we use specific vocabulary to describe where the energy is coming and where it's going. Okay? The substance, in this case, let's use the example of water, okay, is going to have a special name, and it's going to be called the system. Okay? And that the system is anything that you are concerned with, anything that you're looking at. We're looking at water in this example, and that water is surrounded by what we call the surroundings. So you have the system and you have the surroundings. So here's what it would look like. Here is the system, and everything around it, this would be what we would call the surroundings. Okay? So that would be the air, that would be the planet Earth, that would be anything that's not the water. Okay? So important for you to remember that there are two parts to this: the system and the surroundings. Okay? All right. In this case, and we'll just stick with this for now, in this case where we're talking about an energy flowing in, we have energy moving into the system. Okay? And we have a name for this. We call this an endothermic process. And so a good way to remember this is if you look at this part of the word, N, it kind of sounds like the word in. Okay? So energy goes in an endothermic process. All right? So let's have an example of that. All right? So the example that we decided to use today, what's going on here? Let's get my pencil back. Okay. Our example will be liquid water turning into steam, which is the gas phase of water. Okay? And so to get liquid water to turn into the gas phase, we have to add energy. Okay? And so you could add energy by putting it on a stove, you could leave it out in the sun, you could put it on a hot plate, but some way you're going to have to add energy. Okay? Now, what that does is that takes the water molecules, which are at a fairly low kinetic energy, and it gets them moving really fast, okay, until they're moving so fast that they can become a gas. And this is high kinetic energy, okay? So the only way to go from low kinetic energy to high kinetic energy is to put something into this the system. Okay, so the only way to go from low to high is to have added energy, okay, into the system. So we say that the energy goes from the surroundings into the system. And if you look at this word right here, in means endothermic. Okay, so what are the endothermic processes then? Well, there are a few. If you want to melt water, so melting is endothermic. What's another one? Well, if you want to boil water, that would be vaporization. You have to put energy into the system. And then there's one kind of funny one, the strange one where the solid becomes a gas. That's called sublimation. All of these are endothermic processes. Okay? All right. So we have the system, we have the surroundings, you know which way the energy is flowing. What about the opposite? So energy out, okay, would be energy going from the system out into the surroundings. And now I have made a mistake over here. We should change this arrow around. I made a mistake. This arrow should be going backwards, right? It goes in. So in energy flowing out, we have energy leaving the system and entering the surroundings. You could say that the energy is exiting the system. Okay? So the key part to remember here is this little part, EX, exit. It kind of sounds like exothermic, okay? Which is what we would call this process. We would say that energy, therm, exits the system, okay? So let's draw a picture of that. So if we had a gas, okay, here it is, all right, and we cooled it down, we removed energy, okay, we removed energy. The energy has exited the system. Well, what will that cause? Well, if you cool this down enough, you know from previous discussions that that water will change into a liquid. It will condense. Okay? So this is a great example of an energy flow out of the system. This is an example of an exothermic process. Okay? So what are the exothermic processes? Okay, we just talked about this one, condensation. So condensation is one. What's another one? Well, as you go down, what about freezing? Yep. To get liquid water to freeze, you have to remove energy. That's exothermic. And then there's the funny one that skips the liquid phase called deposition. Okay? And so what you've got here then are three changes of state that are exothermic. That are exothermic, okay? And then these are endothermic. All right, so we now know that any change of state can be identified by the way that the energy flows in or out of the system. And we call those endothermic processes if energy flows into the system. And we call them exothermic processes if the energy flows out of the system. And we're able to identify each of the phase changes as either an endothermic process or an exothermic process. Okay, guys. Well, thanks for listening today. And that's the end of our lecture about energy flow in reactions.